Okay, so you've seen some example applications of text mining, and I showed you as a very quick overview how one of these applications is implemented in an NLP framework. Now we talk a bit more in detail about these individual steps and how you can implement each of them. So, as I said in the beginning, what we do here, we can use for all kinds of applications. We talk about NLP, and one example application of NLP is text mining. Another application is in developing dialogue systems like chatbots or intelligent assistants. So on this overview here, you see a number of typical applications for text mining. For example, systems that summarize documents, the LLM system that you worked with summarizes information about various news items. You have seen the example of knowledge extraction, for example, extracting entities from document, applying this to, for example, medical documents. You're all working, for example, with email spam filters. So this is a very basic NLP application. It's a specific kind of classification here, classifying into spam and ham, but this is also being used for other email classification systems. Companies classify their incoming emails into customer requests, orders, other types of emails, and then this is pre-filtered and classified. I briefly mentioned applications like sentiment analysis. When you have to look at online reviews on e-commerce websites, people want to find out what is being said about their product or service. So there are tools that are used by large companies that automatically monitor online forums in communities, product websites, and find out if, for example, something bad is being reported about a new product or a service. It's being used in finance. I showed you the link to the application. Let's just go quickly back here. At the end here, there is a link. If you haven't seen it, you can read the article that is Refinitiv, the one that we looked at earlier in the context of a knowledge base. That was the one that was originally called Open Calais by Reuters. So a very well-known, long-established text mining system. So NLP nowadays is everywhere. Here, we just have basically one lecture on NLP. We'll talk a bit more about it when we come to neural networks and deep learning. But obviously, we cannot go into detail like in an NLP course. So here we focus more on the application side and the system implementation using NLP, and we focus less on how each of these individual steps work, which is something you learn in an NLP course. But you get an idea on the application side. Now, all kinds of domains where you can implement it, and you can see where this is being used in practice. So since we are working with Python in this course, instead of using Gate or UEMA, which work with Java, and they also have a bit of a learning curve to get started, we're going to use a Python library, which is called spaCy. So this is one of the newer libraries in NLP. Earlier I mentioned NLTK, which has been out for a long time. You will see a lot of publications that work with NLTK in the academic domain. spaCy, on the other hand, comes more from the industry side. So there's again a startup that developed spaCy, and it's especially designed and tailored for quickly building applications. Now, for rapid prototyping, which is what you have to do when you're a startup, you want to quickly build a new NLP system. You have somewhat different requirements than when you work with a library for academic purposes. So we'll see that spaCy is quite easy to use. It uses common paradigms in Python that you've also worked with in scikit-learn. So you can quickly get started, and in the lab, we'll walk you through installing spaCy and doing your first steps in spaCy. In spaCy, again, you have the idea of a pipeline. So you do different steps on your documents and they build on top of each other. You start with characters, you tokenize them, you run part of speech tagging, you do a syntax analysis, and so on. So basically, your design decision is for the problem that I have, how can I break it down into individual steps? And for the steps, what kind of processing do I use? Can I use something existing rules, existing machine learning models, or do I have to train it myself? So in general, you can see here the match of the processing step to the application side. The more sophisticated applications you have, like question answering, like in a chatbot over a knowledge graph, you need a lot more deeper processing than when you do something simple like spell correction, for example, which is something you can do easily on the characters and tokens. So earlier I mentioned that some of the code that you work with in NLP is language independent. Reading Unicode characters from a file, it doesn't matter what language you're dealing with. But then when you do processing like part of speech tagging, it becomes language specific. So in spaCy, you have to decide what language you want to work on. And fortunately, for many languages, there are pre-trained models available. Obviously, for the major languages, English, French, German, and so on, but also for a whole bunch of other languages. So online, you can see what models are currently being available and for which steps there are pre-trained models available. So the way you work with is obviously you have to import the spaCy library, and then you create an NLP pipeline by loading a specific language model. So one that we're going to start with in the lab is an English core model, the small version that was trained on web data, on a corpus that comes from the web. Small because this is something you can easily run on your home systems. There's also a larger model, but then you need a bit more memory available to be able to run it. So you have seen the first step after loading in some text is to split it into these tokens, into basic units like word tokens, number tokens, space tokens, and so on. And here it's important that to do it consistently because all the other steps build on top of this. So if you make any mistakes here, they're going to propagate throughout the pipeline and affect all the later processing steps. And again, I mentioned this last time, you might think this can't be so difficult, but there are lots of problems in tokenization. So I showed you some last time. Let's look at another problem here. You have something like John's, like in a phrase, John's sick. So now what do you do? Is this one token because there is no space in here? Do you put all of this together and say this is one token and sick is a second token? So let's say you say this is just one token. And then later you come to a grammatical analysis. Now you have just John's sick and there is no verb. There are two tokens and we need a subject, verb, object, and there is no verb. So we're going to run into a problem. Now you say, okay, let's be smart. We just split this off here because we know this is really an abbreviation for John is sick. So now we split this into two tokens and then we have John is sick and we can easily parse it because now we have a verb, the subject, the object. But now you're happy, it works. And then you come into another document and process John's house. No, the strategy that you just applied for John sick doesn't work anymore. So this is something that will haunt you all the time in NLP. because natural language is messy, ambiguous, and to do it reliably is quite tricky. Similarly, you have to deal with all kinds of different syntactical forms. The same concept, like a database, could be spelled without a space, with a hyphen, with a space. And if you tokenize it differently, you have some trouble later on recognizing that this is actually the same concept. In terms of knowledge base, the same URI. And then, of course, you have lots of other things that can appear. Something like smileys, abbreviations, weird stuff like this, C++, that you have to deal with somehow and consistently tokenize. So Spacey has a couple of tokenizers. If you load the default model, you get a default tokenizer in there that applies a couple of processing steps. For example, here, if you have something like let's go to New York, it goes through a number of rules for splitting off, for example, the quotes, splitting let's up into let and apostrophe F. These are easy. There's no special rule being applied to it. And then again, this New York exclamation mark quote here is again split into 3 different tokens. How do you do it in code? Earlier, remember, we loaded an NLP pipeline. This is where we used a language model. So this gives us an NLP pipeline for English, a default pipeline. And now we can process a document using this pipeline. So this is our document here, and the results will be stored in a doc object. And then in that doc object, one data structure that you have are tokens. So now you can go out and print all the tokens in that document, and for each token, print out the text that corresponds to the token. And you can, again, try this out online. So that's the 3rd task on the worksheet. If you already installed Spacey, of course, you can run this locally, but if you haven't installed it yet, you can also run it online. So try this out. Try a couple of different documents to see how it tokenizes it. And then I'll see you back in the next lecture part.